This video is about inertia. You might have heard of inertia before, but you may not know what it is. So this is all about what inertia is. You probably have heard this idea before, that objects at rest want to remain at rest. For example, a couch. If you try to push on a couch, it doesn't really want to move. It wants to remain at rest. Another great example, a Jenga tower, right? It wants to stay still. That's why you can pull a block from the bottom of the Jenga tower, hopefully if you're good, and the rest of the Jenga tower stays still. If you do it really fast, the rest of the tower stays still all the time and just doesn't move at all, because objects that are at rest, they want to remain at rest. In the same way, objects that are in motion want to remain in motion. So I think of a train as a good example to really illustrate this idea. If a train is moving really fast, it's really hard to stop that train. You want to get out of the way. Objects that are in motion want to keep on going. They don't want to stop. They don't want to slow down. And they just keep going forever and ever. Another example is cutting an apple. So I have an apple here. And I wanted to show you a way to cut an apple. That's maybe not the typical way to do it, but it does illustrate that once an apple is moving, it wants to keep moving. So I've got my trusty knife here. And you shouldn't try this at home, but just watch. So I'm going to cut an apple like this. I'm going to place the apple first just in the middle right here on the knife, so it's just fixed on the knife right here. And then I'm going to let the apple kind of fall towards the ground. Okay, so I'm going to let it fall, but I'm going to stop it right here. I'm going to let the knife hit this book, and the knife is going to stop. But what do we know about objects in motion? When an object is in motion, it wants to remain in motion. So if that's true, this apple should continue to move even though the knife has stopped. Now, my knife isn't very sharp, and I can't really get the apple going very, very fast. So I might have to do this a few times. So just bear with me. Let's try it out. There you have it. Oh, I was going to eat that. So once the apple's moving, it wants to keep going. The knife stopped, but the apple wants to keep going. Objects that are in motion want to remain in motion. Oh, good. It landed in a good place to eat it, so should be able to enjoy that apple still. So you might have heard of Isaac Newton. This idea of inertia comes from him. He's an Englishman, and he identified this phenomenon of objects in motion wanting to stay in motion, objects at rest want to stay at rest. He identified this as a scientific law in 1687. And just as a side note, a scientific law is something that it seems to always be true. It appears to be always happening in nature based on repeated tests and experiments. It seems like this always happens. And we call it a law after enough time has passed where enough people have done experiments on it, and it seems pretty likely this is always going to happen. So objects always remain at rest, for example. So here's his formulation. It's called the Newton's first law of motion. An object at rest stays at rest, and an object in motion stays in motion. A little extra detail here, with the same speed and direction. So once it's in motion, it's going to keep going at the same speed in a straight line until acted on by an unbalanced force. We'll talk about what that really means later on, but objects want to keep on doing what they were doing. In other words, all objects resist change. They don't like to change what they were doing. This property of an object is called inertia. That's where we get the word inertia from. Inertia has a smaller part of that word is inert, which means inactive, lazy, not doing anything. Maybe like you are on a Saturday. That's how I am. But inertia is this property of an object. It's not a force. So inertia, like a train moving, is not a force. It's a property of the train that it wants to keep moving. It's just something that train possesses as a characteristic. That's why we also say that Newton's first law of motion is called the law of inertia. They use the same name. First law, law of inertia, it's the same. Another way to say this, and I like to say it this way too, objects are naturally lazy. They don't want to change their velocity. They want to maintain it. They want to keep it the same. And one of the key relationships with inertia is that the more massive an object is, the more inertia it has. So a great example of this, if you've ever pushed a shopping cart around Walmart, if the shopping cart is empty, it's pretty easy to change its motion. It's easy to make turns. It's easy to stop it. It's easy to get it going. It's no problem. Not much inertia. Inertia is that laziness. It's pretty easy to change it and move it around. On the other hand, if the shopping cart is full, it's pretty difficult to change its motion. Now, it's not difficult necessarily to, you can get it going pretty fast, but once you get a shopping cart going pretty fast, full of stuff, it's hard to stop it. It's hard to change it, right? So once it's more massive, once it's got more stuff packed into it, it's a lot harder to change its motion. So remember, inertia is this resistance to change the motion. So that's all I have for you in this video. Remember, how you do anything is how you do everything. Thanks.